Hey, Algebra crew. All right, today we are doing section 10.6, which is about trig ratios. And trigonometry is probably one of the most in-depth sections that we're going to be doing. So you're definitely going to want to pay attention here. And there are some rules that you have to follow with trig, but once it clicks, it's very easy. And you will need a scientific calculator for this section and for the quiz that you're going to get on this, all right? So you're going to want to, I have a graphing calculator. You can also use the smaller scientific calculators as long as you see sine, cosine, tangent. And notice right above those buttons is sine to the negative first, cosine to the negative first, tangent to the negative first. We will be using those. Those are called inverse trig functions, okay? So first of all, we have a right triangle. This is right triangle trigonometry, okay? So this is our right angle, okay? And with trigonometry, the key is deciding where you're going to place yourself on the triangle. You almost have to shrink yourself down to the size of like a little bug, all right? And then you place yourself either on this angle or this angle. And we're going to call this angle A, and this is angle B. And we'll call this angle C. We are never going to be placing ourselves on angle C, only on A or B, okay? So that already rules this angle out. We're either going to be standing on angle A or angle B. And for argument's sake, all right, for right now, let's just pretend that I place myself, all right, over here on angle A, all right? So I'm focusing on angle A, all right? The reason it's so important to have an angle that you're standing on is because, once again, after you place yourself, all right, you need to name the sides, okay? So step one, place yourself on an angle, either A or B. Step two, name the sides. Well, one of the sides is super simple, all right? This side, which is opposite the right angle. It's opposite the right angle. This little arrowhead, all right, always points to the hypotenuse. All right? And I'm always just going to abbreviate that as H whenever I'm naming my sides, okay? And now the side that you can touch, if you were standing on angle A, you could reach down and touch this side length. You could touch it right there, all right? Now, some students will be like, oh, well, I can touch this side too. Well, but this side is the hypotenuse, and it's always the hypotenuse. So the other side that you can touch, that's called the adjacent side, okay? The adjacent side. And then the side that you can't touch, way over here, you can only look at this side, that's called the opposite side. All right, that makes sense because it's opposite where you're standing. And adjacent makes sense because if you're adjacent to something, you're really close to it, you're next to it, you can touch it. All right? And that's why it's so important to place yourself in a specific angle. Because look what happens. If I were to come down here, if my little guy, walks down here and he wants to sit on angle B, all right? Notice how the hypotenuse, once again, will not change names, but notice that this is now the side that I can touch. So this would be adjacent, and this would be opposite. So depending on where you're standing, either A or B, that will determine the name of this side and the name of that side, all right? So let's just pretend that we're not standing on angle B, we're standing up at angle A, and we're going to use these names, all right? So for right now, we're just going to stand on angle A, all right? Well, the sine of angle A, all right, is equal to opposite side over hypotenuse, all right, or O over H, okay? The cosine of angle A is going to be equal to adjacent over hypotenuse, A over H. And then the tangent of angle A is equal to opposite over adjacent, okay? You need to know these ratios. Whatever these side lengths equal, that's what you plug in over here, okay? And these ratios don't change. So for instance, let's say I was standing on angle B. The sine of angle B is still going to be opposite over hypotenuse. But notice the opposite side, if I was standing on angle A, is right here. The opposite side, if I was standing on angle B, would be over here. So those numbers would change, but the ratio does not change. All right, the cosine of angle B is still adjacent over hypotenuse. And the tangent of angle B is still opposite over adjacent. Those don't change, all right? But if I was standing on angle B, this would then be my adjacent side. This would still be hypotenuse, all right? And this would then change to opposite, all right? So if I'm standing on the green angle, notice this is opposite, that's adjacent. If I'm standing on the pink angle, this is adjacent, that's opposite. So make sure you follow the steps. The first step, put yourself on one of these angles. Second step, name your side lengths, okay? Name the side lengths. Now, there are two rules that you must follow with trigonometry, okay? The first rule, whatever the angle measure is, must go next to the trig function. That number goes next to the trig function. So this, if they give you, like let's say they tell you angle A is 40 degrees, then this would say the sine of 40 degrees is equal to whatever the side lengths are. Let's say they tell you that angle B is 60 degrees. So it would be like cosine of 60 degrees equals adjacent over. So the angle measure always sits next to the trig function. You might want to write that down. The angle measure always sits next to the trig function. Now, the second rule, which you must follow, okay? Now, oh, and really quickly, with that first rule, the angle measure always goes next to the trig function. Sometimes they'll be asking you to solve for one of these two angles. They will say, what is the measurement of angle A? Well, that would be your x, or your variable. That still goes next to the trig function, so it would be the sine of x equals blah, 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 okay? Whatever it is, whether the angle is known or it's unknown, it must go next to the trig function. Now, that goes into rule number 2. If you don't know the angle measure, if you have sine of x or cosine of x or tangent of x, then that's when you will be using sine -1, cosine -1, or tangent -1. Those are called inverse trig functions. If you don't know the angle, then you use the inverse trig functions. And in order to get that on your calculator, you have to push the second button first, all right? So you would push the second button first, and then you push sine. Notice how it says sine to the negative first power. Okay? So those are the rules, and you have to follow those rules. Now, let's do some problems. Okay? I'm going to do the 5 problems and maybe an extra one on page 649. All right? So, oh, and one other thing here. How do you remember that these are the ratios? Well, there's something called SOHCAHTOA. Don't spell it wrong. So there's SOHCAHTOA. What this stands for, the sine equals opposite over hypotenuse. Sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. Tangent equals opposite over adjacent. So if you can just remember SOHCAHTOA, then that will help you, okay? So let's start doing these problems and see how we do, okay? So let's do problem number 1. And problems 1, 2, and 3, they are all using this triangle, all right? There's my 90 degrees, all right? And this is A, this is C, this is B. They tell me that this is 10, this is 8, and this is 6. Once again, they just want us to write the trigonometric ratio, okay, for angle A. So they say, what is the sine of angle A? They want the numbers. Once again, we have SOHCAHTOA, right? SOHCAHTOA. So the sine of angle A, that means we come over here and we're standing on angle A, all right? So let's name our sides. This would be hypotenuse because it's opposite the right angle. This is the side that you can touch, so we'll call that the adjacent side. And then this is the opposite side because I can't touch it. I can just look at it. According to SOHCAHTOA, the sine is sine opposite over hypotenuse. So the opposite is 8. The hypotenuse is 10. So it would be 8 over 10. All right? And that can be reduced to 4 over 5. All right? Number 2 says, what is the cosine of angle A? Once again, we're standing on angle A, so our names don't change. The cosine is adjacent over hypotenuse, so 6 over 10. All right? So 6 over 10 can also be written as 3/5. And then number 3, we have the tangent of angle A. This equals opposite over adjacent, so 8 over 6. All right? Which can be reduced to 4/3. Now, we didn't need to do anything on the calculator there because all that they were asking us to do was give the trigonometric ratio. That's it. And here's the ratios: 4/5, 3/5, 4/3. Now, they will ask us to solve some problems. So, let's look at number 4, okay? Number 4 says, and they don't give us a picture. So guess what? We are going to draw a picture for number 4. And with all of my problems, I always rewrite SOHCAHTOA just so I know what the ratio is. So it says a right triangle. I'm going to stop right there, and I'm going to draw a right triangle. Any arbitrary triangle, it doesn't matter. All right? There's my right triangle. It says it has a 40-degree angle. Well, I'm going to write a 40 over here. Okay? 40-degree angle. The hypotenuse is 10 centimeters long. Well, the hypotenuse is right here, all right? That is opposite the right angle. What is the length of the side that is opposite the 40-degree angle? Well, now we have to make sure we label this correctly. The side that is opposite would be right there. So now we're getting into where we need our calculator. We need to solve for x. And remember, rule number 1, the angle measure always goes next to the trig function. But now the question is, oh my gosh, what trig function do I use? Well, what are the side lengths that I have? I have an x on the opposite, and I have a 10 on the hypotenuse. Opposite and hypotenuse together here uses sine. So I'm going to say the sine of 40 degrees is equal to opposite over hypotenuse, x over 10. And then we solve for x. So how do we get the 10 over here? We multiply both sides by 10 because it cancels here. So now I'm left with 10 times the sine of 40 is equal to x. So let's take our calculators, and it's very important to do something before we solve this. We need to make sure that our calculators are in the correct mode. So you push that mode button. Mode. Look at 3 lines down. We can choose radian or degree. Radian or degree. Highlight degree, just like I've done. Push enter. All right, nothing will happen. It'll just highlight that. Now it's blinking. And then exit out of it by pushing second and mode again. Your calculators are now in degree mode. That doesn't change anything, except that's the mode we want for trigonometry. Now we can do our problem. And I'm just going to type it in exactly as I see it. 10 times the sine of 40. So I take my calculator, 10, I push the sine button, and then 40 degrees. And I'm going to close that parenthesis there, all right? I push enter, 6.4. So I know that x is equal to 6.4. All right, so I just solved for that side length, which is pretty cool. All right, let's do number 5. All right, number 5. All right, number 5 says a right triangle. Okay, so once again, we need to draw a right triangle. Notice how I typically just draw my triangles the same way, because it doesn't matter. This is just for your visualization, okay? So a right triangle's legs are 7 and 24. They didn't say anything about this side, which is the hypotenuse. They said the legs. These are the legs. The legs form the right angle. So I'm going to say that this one is 7 and this one is 24, okay? What is the measure of the angle that is opposite the 24-inch leg? Here's 24. What angle is opposite? Is it this one or is it this one? Well, it's not this one because I can touch it. If I was standing there, I could touch it. That would be adjacent. So I know I have to come down here and put my x degrees. Now remember, rule number 1, the angle measure always goes next to the trig function. So I need SOHCAHTOA first. What side lengths were I given? Adjacent and opposite. So adjacent and opposite uses tangent. So tangent of x degrees is equal to opposite over adjacent, 24 over 7. Now, the second rule said when you don't know the angle measure, you always use inverse trig. So the easy way to solve this, x is equal to inverse tangent, remember, tangent to the negative first power, of 24 over 7. So I go to my trusty calculator, all right, and I type in inverse tangent. Notice I had to push the second first. Inverse tangent of 24 divided by 7. So I got 73.7 degrees. There you go. So that angle right there is 73.7 degrees. Now, I've done two examples here where I had one example where your variable was in the numerator. I had one example where there was the unknown angle measure. So I'm going to do one more problem. I'm just going to make this problem up. All right. And I'm going to say, we'll call this number 6. All right, number 6. And I'm just going to draw a triangle, a right triangle. We've used sine, we've used tangent, so let's try a cosine one. All right. And let's say they tell us that this is 70 degrees. All right. And we don't know the hypotenuse. And they tell us that this down here is 10. Okay? Once again, what angle am I standing on? Standing right here at the 70. This is adjacent. This is hypotenuse. That tells us with SOHCAHTOA, if we have adjacent and hypotenuse, that's cosine. So the cosine of 70 degrees is equal to adjacent, 10, over hypotenuse, which is x. Here's a fun little trick. Remember, when the variable was in the numerator, all we did was multiply both sides by the denominator. When the variable's in the denominator, you can just switch spots. You can just switch spots. So I'm going to put the x over here, and I'm going to put the cosine of 70 in the denominator where the x was. And then I get my trusty calculator, and I do 10 divided by, this is regular cosine, all right, because we're not solving for an angle here. You only use inverse trig if you don't know the angle, and that's what you're solving for. We know the angle is 70. So 10 divided by the cosine of 70, I got 29.2. So I know that x, the hypotenuse, is equal to 29.2. I know this was a long video, but there's a lot to trigonometry, and I wanted to make sure that everybody was understanding this. Okay, make sure you look at this video multiple times if you need to. All right, and hopefully everybody's staying healthy. Hopefully you're doing your work, and just be ready for a trigonometry quiz. All right, coming up. So have a great day.